Everyone, welcome. Today we will solve exercise 1.1 from the chapter sets. So main question 1 says that which of the following are sets and justify your answer. So let us see questions one by one. Sub question 1. They are talking about months in a year which start with J. So is it a set or not? When we look at it, if I try to write it as a set, okay, A is equal to, in the theory part we have known that if you are writing by roster method, you write the letter A or B or C capital letters for the name of the set, then braces or flower brackets, and inside you write the elements, right? So which all are the months which starts with J? You have January, right? Then February, March, April, May, June. There you go again, June, July, August, September, October, November, December. Over. Only these three. So these three are the months which start with J. So no matter whom you ask, they have to give the same answer. So this means the given collection is well defined. Then this is called as a set. So we can write yes. The given collection is a set. Justification, because it is well defined. The second sub-question says that 10 most talented writers of India it's speaking about. But this cannot be a set. Reason? Suppose one person says, I believe that Ruskin Bond, Chetan Bhagat, Arundhati Roy are very good writers. Somebody else must say that no, I think that R.K. Lakshman and Salman Rushdie, they are the best writers. Then this is arguable. From person to person, the collection changes. In this case, this is not a set. A set should be well defined. No matter who is giving the answer, the set or the collection should be same. Here the collection may vary. So, no. This is not a set. This collection is not a set. Sub question says, it talks about cricket batsmen, right, from all over the world. Now this is again arguable because some of us may consider that okay, all the Indian batsmen are the best ones, so we will put all the Indian batsmen in the set, right? But somebody else who is not from India may find that okay, Australian batsmen and South African batsmen, they are better than Indian batsmen. At that time the names keep on changing. The elements of the collection will not be the same always. It will change from person to person. That's why this is not a set. So the answer is no. As from the second sub question, the same answer you can write. This collection is not a set. Fourth sub question says, the collection of all the boys in your class. See, if you are from a particular class, if the names of all the boys are written in an order, no matter who is writing that, it might be your class teacher, it might be your monitor, it might be a staff in the college, but the list of names should be same. The arrangement can be in any order. You remember in set what happens, the order is not important, which is written first, which is written second, that is not important, but the elements should be same. In that case, if we write the names of all the boys in your class in a list or in a collection, then all of them should be the same. No matter you go to ask anybody in the class, they have to give the same answer. So we are particularly talking about one class. You may have an argument. What about if you go to another class and ask about it? But I am talking about one special class, one particular class. If I am talking about your class, suppose it's first year A section. Even if I go to second year A section and ask what are the names of the boys in first year A section, they have to give the same answer. So no matter whom you go to and ask, the list remains same. So this is a set. So fourth one, Yes, it is a set. Question says that collection of all natural numbers less than 100. So since you know natural numbers, we can write it as n is equal to, okay, where do natural numbers start from? Counting numbers, 1, right? So 1, 2, 3. We won't have enough time and space if we go on writing all the numbers now, but we know that we are supposed to write all the collection less than 100. Less than 100. In that case, this continues till 99. No matter who writes this answer, no matter whom you ask, natural numbers always remains 1 to 99 if you are talking about numbers less than 100. We are not talking about integers, we are not talking about rational numbers, we are talking only about natural numbers. So, natural numbers must be starting from 1, 2, 3 like that till 99. I can't count 100 because they have strictly given lesser than 100. See, if they had asked lesser than or equal to 100, not strictly but less than equal, then this set would also contain 100, but now strictly they have asked less than 100. In that case, this is the set. So, is it a set or not? The collection is same no matter who says. So, you can say yes, a big yes, it is a set. Sub question number 6 says that it is a collection of novels written by the famous writer, that is Munshi Premchandji. Okay, so in that case, is this a set? See, let me just show here all the novels, the 16 famous novels written by Munshi Premchandji. So no matter whom you ask, those who know the answer, those who know all the novels written by him, will have to give the same number of novels, the same 16 names or the same 16 elements. In that case, it is a well-defined collection. If it is a well-defined collection, then it is a set, because no matter who writes, you are going to get the same collection. So, yes, it is a set. 7th sub-question says that collection of even integers, all the even integers. So, let us try to write this collection. So, if I call it as even integers, I will call it as E. You can take any name. E is equal to, so even integers, 0. 0 is an even integer. See, most of the students get confused. Is 0 even or odd? It is even. See, when you are talking about positive and negative, 0 is neither positive nor negative. It is neutral. But if you are talking about even or odd, any number which gives 0 as the remainder, when you divide it by 2, that is called as even. If you divide 0 by 2, the remainder is again 0. That means it is an even number. So, if any number gives 1 as the remainder when you divide it by 2, that number is called odd number. This is even number. The next even number being 2, which is also called as plus 2. Also, negative 2 is also, minus 2 is also an even number. So, you can write plus 2 and minus 2. Together I can write them as plus or minus 2. Right? Similarly, next even number, plus or minus 4. If you divide 4 by 2, the remainder is 0. So, positive 4 and negative 4 both are even numbers. Similarly, as we continue, plus 6 and minus 6. So, plus or minus 6, plus or minus 8, and so it continues till infinity. No matter who writes, the answer has to be same. Even numbers, they cannot change into 1, 3, 5, which will become odd numbers. So, those who have the knowledge of this, they must write the same answer, means it is well defined. It doesn't change from person to person. So, you can write yes, the given collection is a set. Sub question number 8 says that collection of all those questions in this chapter. So, is it a set? See, when we are dealing with this chapter, we are talking about this chapter, that is a chapter of sets. If you count all the questions of each exercise, the main questions or the sub questions, no matter who is counting it and who is saying it, everybody will have to give the same answer. That means it is a set? Yes, the given collection is a set. Sub question number 9. Okay, the last question of this main question, but not the least one. The collection of most dangerous animals, okay, in the world we are talking about. So this is subjective. It may change from one person to another person. Imagine, for one person, if you're talking about snakes are dangerous, crocodiles are dangerous, but somebody who is taking care of these, for that person it may not look as dangerous. There is a person in China who is taking care of an alligator or crocodile. He carries that for walks. Now for that person it's not dangerous. Or if you're talking about hunting dogs, the person who is taking care of hunting dogs, for him it is not dangerous, but other people may find it very, very dangerous. If you talk about tigers and lions, obviously we would say they are dangerous, but some people take care of these animals. They may not find them as dangerous. And the worst of all, human beings, they are the most dangerous one. But obviously, human beings will say, we are the least dangerous. So, like this, it changes from one person to another person. So, this is not a set. They have asked you to justify the answer. You can say, no, the given collection is not a set because the collection is not well defined. It changes from one person to another person. Main question number 2. So, main question number 2 says that if A is a set containing 1, 2, 3, 4, 5, 6, okay, there are 6 elements, 1, 2, 3, 4, 5 and 6. Now, these are the elements belonging to A. You have to use symbols epsilon, which is belongs to, and striked out epsilon, which says does not belong to. Appropriately, you have to fill in the gaps provided in the sub-questions. Let us have a look at the sub-questions. So, first sub-question says 5-A. 5, does it belong to A or does not belong to A? 5, yes, it is there in A. A contains 5. So, you can say 5 epsilon, which means belongs to A. Next, second one, 8. 8, do you see 8 in this set? 8 is not an element of A. If it is not an element, you can say striked out epsilon means does not belong to A. How do you read it? 8 does not belong to A. See, at any point, if you have doubt regarding the symbols or something, please refer the theory video. Okay, let's continue. 0-A. 0, do you see 0? No, 0 is not an element of A. So, you can say 0 does not belong to A. What about 4? 4, yes, 4 is there among the collection. So, I can say 4 belongs to A. Epsilon means belongs to. 2, yes, of course, 2 belongs to A. What about 10? Do you find 10 in that? There is no 10 there. It means 10 does not belong to, means epsilon striked out. That's the answer, as simple as that. Third main question says that you have to write the given sets in roster form, means they have not given in roster form, they must have written it in the other form, which is that set builder form. We have to change it into roster form. Let us look at the sub question one by one. Sub question 1 says that A is a set of all x. I hope you remember how to read that symbols. A is equal to is called as is a set of all. Is a set of all x such that x is an integer. You remember integer, right? From the set called z. Yes? Yeah. So, x is an integer and x value lies between two values. Which are the two values? It should be greater than to 3. Means 3 is lesser than or equal to x. Means x is greater than or equal to 3. And x is lesser than 7. So, what are the values which can write in A? So, A can be equal to, which all values satisfy this? Shall we start from 2? No, because x has to be greater or equal to 3. So, 2 is not greater, neither is it equal. So, we can start with 3. Is 3 okay? Yes, fine, because equal to 3 is fine. Greater than 3. Next integer is 4. Can I write minus 4? No, it is way smaller than 3. We should need bigger numbers than 3. So, 3, 4, fine. 5, is it bigger than 3? Yes. So, 5, 6, yes of course. 6, 7? No, because the numbers have to be lesser than 7. And all these numbers are lesser than 7, but not 7 itself. Had they given lesser than or equal to, you could have written as 7. Now we cannot. So we stop this. So the property what they had given, that was x should lie between 3 and 7 such that it can be equal to 3. So we started with 3, but strictly lesser than 7. This is the roster form for the given set. Second sub question. Second sub question says that B is a set of all x. Remember how to read the symbols. B is a set of all x such that x is a natural number. You remember natural number, right? Counting numbers. X is a natural number and x is strictly less than 6. Strictly less. It's not lesser than or equal to, strictly lesser than 6. So let us try to write the set. B is equal to, so this time I am writing the actual elements, not the property. So it should be natural number, starts from 1. Is 1 less than 6? Yes, of course. What about 2? Is it less than 6? Yes, we can write 2. The next natural number, 3, 4, 5, 6. No, because 6 is not less than 6. It is equal to 6. So we have to stop at 5. 3, 4, 5. Let us stop at that. These are the actual elements. So this is called as roster method. This is like writing the list. So when you go to shop to buy groceries, you have a list in the hand, right? All the things, salt, sugar, tea powder, okay. You know the elements exactly by their names. That is called as roster method. Whereas rule method, only the property of that is told. Example, you are getting a dairy product which should be white in color, okay, which can be stored in the fridge. Now we are talking about maybe curds, maybe milk, maybe butter, right? We are talking about many things there. So we are only saying the property there, but not the actual elements. That is set builder form. This is roster form. Third sub question. C is a set of all x such that x is a natural number, 2-digit natural number, and such that the sum of the 2 digits when you add, it must be equal to 8. So you know that 2-digit numbers start from 10. Before that are all single digit numbers. So from 10 onwards, the last number is 99. Because after that you have 100, which is a 3-digit number. So in natural numbers, we are looking between 10 and 99, 2-digit numbers, right? In that, choose only those numbers whose sum should be equal to 8. If you look at the first 2-digit number, 10, it's 1 and 0. Add 1 and 0. It's 1, not the answer. 11, 1 plus 1, 2, not the answer. 12, 1 plus 2, not the answer. Then which are the answers? Let's try by trial and error method. If you go on checking all the numbers, these are the numbers what you will find. So C is equal to, first numbers that you see is 1 and 7, 17, isn't it? Add 1 and 7, it is 8. The sum of the 2 digits is 8. That is the first number is 17. Next, go on, 18, 8 plus 1, 9, no. 19, 20, 21, 22, 23, 24, 25, 2 plus 5 is 7, no. 26, 2 plus 6, 8, yes, 26. Next number is 26. Add 2 and 6, 8, correct. 27. 9 it is, 28, no, 29, 30, 3 plus 0, 3, no, 31, 31 is 4, 3 plus 1 is 4, 32, 3 plus 2 is 5, no, 33, 34, 34 is 3 and 4, that is 7, 35, yes, 35, add those two, 3 and 5, 8, similarly, 44, then 53, then 62, right? 6 and 2, 8, 7 and 1, 71, that is 7 and 1 is 8. Next number, 8 and 0, 80. We did not write 0 and 8 here, right? 0 and 8 we did not write because it is a single digit number. But 8 and 0 we have written because 8 plus 0 is 8 and it is a double digit number. Any number bigger than this, the addition is going to be bigger than 8 but not equal to 8. So this is the final answer. 17, 26, 35, 44, 53, 62, 71 and 80. That is the roster form for the given question. So, sub-question number 4. So, here we are talking about x such that it is a divisor of 60, but it has to be prime. So, it is a prime number and also it is a divisor of 60. Let us have a look at such numbers. So, let's start with 1. 1 is not a prime number, you know that, right? And a prime number, when we are discussing, we are not talking about negative prime numbers. We are only talking about positive prime numbers. So, 3, 2, sorry, let's start from 2. 2 is a prime number, yes. Does 2 divide 60? Yes. 2 times 30 is 60, right? So, that means 2 is a divisor. 3, is it a divisor of 60? Yes. 3 times 20 is 60. So, 3 divides 60 perfectly. That means 3 is a divisor. 4, is it a divisor? Yes. 4 into 15 or 4 times 15 is 60. So, but 4 is not a prime number. So, I cannot write it there. It is a divisor. However, it is not a prime number. Next, 5. Can I write 5? Yes, of course, because yes, 5 into 12 is 60. So, 5 is a divisor. 5, is it a prime number? Yes, of course. Next, 6. Can I write 6? 6 tens are 60, but 6 is not a prime number, right? It's not a prime number. It has factors, that is 2 and 3. Other than 1 and itself, it has 2 and 3 as factors. So, 6 is not a prime number. It's a composite number. So, 6 I cannot write. 7, it does not divide 60. So, it does not a divisor. However, it is prime, but it is not a divisor. 8, not a divisor. 9, not a divisor. 10 is a divisor, but it is not a prime number. As we continue like this, you will see that all the remaining numbers that divides 60, okay, all the divisors of 60, they are all composite numbers. The only prime numbers are 2, 3 and 5. So, that is the roster form for the given set. Sub-question 5 says that E is a set of all letters of the word trigonometry. So, let us try to list the names. E is the set which is equal to trigonometry letters. Letters in trigonometry. T is there. Yes. R is there. Fine. I, trigonometry. G is there. O is there. So far so good. O, N. N is there. Again one more O is there, but we will not repeat. If you remember the theory, the elements are not repeated. So, one more O, no need of writing. Okay, trigonometry. M, M is there, right? E, sure. E, is it written once? E, no. It's a name E is there, but element E is not there. E, then T, metry, T, already written. So, I cannot repeat. R, Y, R is already there. I cannot write. Y is not written. So, I can write it Y. So, these are the elements in the set which contains the letters of the word trigonometry. So, you please be careful. None of the letters should be repeated. Question number 6 says that F is a set of all letters from the word better. Better. So, let us see F. So, from better, let us choose the letters. B is there? Yes. Then there is E. Okay. T. There is one more T, but no need of writing because T is already written. Next is E. E is already written. You don't have to write it again. And the last letters R. R not written. So, once I will write it. See, it's B-E-T-T-E-R, but E and T are repeated, which will not be written in the set form. So, in the roster form, we will not be repeating the letters. So, there are only 4 distinct elements in that set.